You're listening to the Talking Air Filtration Podcast, where you get to know the people that make air filtration possible and help us all breathe easier. Because clean air matters.
We'll get insights from air filtration professionals and learn how they became successful in their careers. Along the way, we will discuss best practices, guidelines, trends, and challenges in air filtration in a variety of applications. We hope HVAC, air filtration, and indoor air quality pros, including business development, engineering, building owners, and facilities management, will enjoy the insights our guests will bring to this podcast.
Why is molecular filtration needed? In addition, a survey of standard molecular filtration products, how to select them, when to replace them, will also be covered for both new and existing HVAC systems. Please welcome Sean Gilstorf, president of DMARC, and Dave Schaaf, the gas phase product manager at AAF Flanders.
Thank you. So Sean and I are going to tag team this presentation, so we'll go back and forth a couple times. Hopefully that breaks up if one of us is a little more monotone than the other. Just a reminder, if you like the presentation, I'm Dave Schaaf. If you don't like the presentation, he's Sean. Okay. What we wanted to do is hopefully kind of whet your appetites on what exactly is molecular gas phase filtration, provide kind of a brief overview, and then hopefully have some time for Q&A at the end. So why and what? What is molecular filtration? So all these names that are on here, if you see this, a lot of people don't even know when they are working on a job or have an application if molecular filtration is required. If you see any of these terms that are on here, it's a molecular filtration job. My all-time favorite is charcoal. That's what people see. Oh, I need a charcoal filter. All right, you're talking about some sort of molecular filtration then. We tend to like to call things gas phase filtration or molecular filtration. But any of these terms, if you see them, it's referring to some sort of molecular filtration application. So why do you need molecular filtration? Well, you need it because the contaminants we're talking about removing are at such a small level that even the best particulate filter, which would be a HEPA or ULPA filter, can't filter out those contaminants. So if you look at this chart, depending on if you're a table-driven person or you're a visual learner, we got both of them up here. You can see on the table on the left, the graphs, particulate matter is on the left-hand side, the gas phase products, contaminants are on the right-hand side, and hopefully you'll see that the gas phase contaminants are several orders of magnitude smaller. So you're not going to be able to remove them on a particulate filter. They're going to just blow right through unless they get caught up in the dirt and dust that's on the particulate filter. Then they might get filtered out, but they're just going to sit there on the surface. So molecular-based or gas phase components are much smaller, as you can see. You can see some of the size ranges on the chart. Typically, molecular contaminants fall under one of these three categories, and a lot of times, most always really, they fall under at least two categories, sometimes all three: corrosive, toxic, or odorous. Most molecular filtration, I would say, falls under the odorous category, and then corrosive would be second most popular, and then toxic. Not a lot of people like to dabble in that category because typically you're talking about things like war gases, where we protect, like U.S. embassies all have gas phase filtration to protect from war gases. But you can see down at the bottom are some typical, in case everybody doesn't remember their high school chemistry, some typical contaminants. So like looking under corrosive, hydrogen sulfide, that's that rotten egg smell, in case anybody's not familiar with it. So it's very corrosive, but also it's very odorous, unless for some reason you happen to like the smell of rotten eggs. And then you can see chlorine, the next example, Cl2. That covers all three categories. It's considered all of those. And then there's some other contaminants that might fall under just one category, not the other. Typically, if you're working on some sort of molecular filtration job and you don't know what your contaminants are, if you can at least narrow it down to it's odor-causing contaminant or it's causing corrosion, that'll at least get you started on where you need to go, what kind of product you might need to remove those contaminants. So what exactly is molecular filtration? Well, it's very different from particulate filtration. And the definition of it, as you can see, is it's removing unwanted gases or vapors from the air. So, you're talking about gas phase components as opposed to solid matter. The methodology for which it works is adsorption. As you might see there, that's a D. A lot of people think it's absorption with the B, like a sponge, you're absorbing things, but it's adsorption. So what you're doing is you're collecting, you have contaminants that are coming through the air. You have a gas phase or chemical media that you're going to use to filter out those gas phase contaminants, and they're going to collect on the surface, and that's physical adsorption. The other way which molecular media works is through chemical absorption, also called chemisorption. And that's where you have that same process. The contaminants are actually being caught, trapped on the surface area of the filtration media, but then there's a chemical reaction. And there's a couple examples here on this slide. So for example, you may have an activated carbon impregnated with potassium hydroxide, the KOH, and say you're trying to remove chlorine with that. That contaminant would get caught on the surface. The chlorine it would interact with the potassium hydroxide and turn into an inert salt, potassium chloride. So the example below is kind of the same thing. If anybody has any familiarity with chemical media, in addition to activated carbon, the most other popular type of chemical media is potassium permanganate, impregnated alumina, purple pellets. And so the next example is you have potassium permanganate, you're trying to remove hydrogen sulfide, and again, you're turning it into an inert salt. So that's chemical absorption versus physical absorption. And the way both of these work so well is if you can imagine if you had enough activated carbon, or it could be alumina, in your hand, just what you might be able to comfortably carry in your hand without it spilling out. If you unfolded that media and spread it out, you would cover 4 football fields. I mean, it has that kind of crazy surface area, which is what it allows it to do molecular filtration. So there's different substrates. I've already mentioned a couple that are used in molecular filtration. Activated alumina, which I just mentioned. Zeolites are also popular. And then activated carbon, I would say, by far is the most popular substrate. And activated carbon can be made from a lot of different materials. Coconut shell is probably the most popular today, followed by coal. And then there are some people that even use wood. Those first 3 are by far what's most prevalent, but some people will use walnut shell, macadamia shell, any kind of nut shell you can actually use. Those tend to be more expensive and you don't see them as often in the industry. And I've even seen activated carbon, as crazy as this may sound, made from bones. It can be anywhere, but most of it is going to be the coconut shell and the coal by far. When you buy a filtration product, that'll be what it's made from. So this is kind of wrapping up everything I just said so far, talking about some typical applications. On the left-hand column on this chart, you'll see different types of the chemical media. The top one being the impregnated alumina. Next one down is just virgin activated carbon. And when I say virgin activated carbon, I didn't make up that term. It's an industry term. It's been around forever, but that just means it doesn't have any chemical in it. It's just plain activated carbon. Whereas those bottom 3, the next 2 down, are impregnated carbon. So there's some kind of chemical that's been put on or mixed into that media. And then the bottom's a blend. So the first column's the type of chemical media. The middle column is if there's some sort of impregnant, what it might be. And then the third column over is the type of contaminants that particular product can remove. And this is very useful because a lot of times what I see in gas phase or molecular filtration applications is somebody will say, I have a molecular filtration application. Tell me about it. And that's all they can tell you. Sometimes, though, however, they'll be able to tell you, well, I know I have hydrogen sulfide present. So you can say, okay, you've got hydrogen sulfide present. Do you know what the concentration is? 90+%, almost 100% of the time, they'll say, no, I have no idea. Well, at least if you can get them to tell you what the contaminant is, then you could look at this chart and say, okay, H2S. You can see several places here where H2S could be removed. You would know from that what media type to use. So very often in molecular filtration, almost always I would say, you're not given all of the information you need, but if you can get a little bit of information, you can at least start going down the right path. So these are various types of media. the impregnants, if there is an impregnant, and what they can remove. The very bottom line is very typical. We see this a lot if somebody doesn't know what they're up against. I have no idea what my contaminants are. I have no idea what the concentrations are. That is a blended media that's 50% activated carbon and 50% potassium permanganate impregnated alumina. It will remove just about everything. It won't remove high concentrations of everything, but it will remove a little bit of everything. So a lot of times when people don't know what they're up against, they'll ask for that blended media. It's also very popular for like hospital helipads, diesel exhaust, a lot of applications where you have a combination of contaminants.
Are your air filtration personnel NAFA certified? Ask if they belong to NAFA and have their certified air filter specialist or NAFA certified technician designations. The CAFS and NCT designations are earned after rigorous exams and demonstrate that the air filtration professional has a high degree of knowledge and professionalism. To learn more about NAFA certifications, visit nafahq.org.
With that, I will turn it over to Sean to talk about some products.
Thanks, Dave. Yeah, so as Dave just kind of went through how carbon works, how chemical medias work, I'm going to try to go into a little bit of the products that are used in the HVAC market. So the simplest is a pleated filter. So essentially, you're taking a nonwoven that is loaded with chemical media, whether it be the carbon or the blends that Dave was talking about, and you pleat it, just like you would a normal particulate filter. So there's several different pleats that we're going to look at, from just standard pleats up to some filters that are a little bit better. So when I talk standard pleats, we're talking about pleats that are in die cuts. So everybody's familiar with die cuts. It's a pretty standard product. 1 to 4 inches, sometimes they can be all the way up to 6 inches. Typical carbon loading ranges from 50 grams per square meter up to 650 grams per square meter. And I want to emphasize that carbon load matters depending on what you're trying to go after. So if you have a very, very small, weak nuisance odor out there, a lighter carbon loading will probably work just fine. But take that odor and make it 10 times worse, you're going to want a heavier loaded carbon filter. So just to give you a little bit of an idea on a filter, a 24-24-2 filter, if you had a 100 grams per square meter loading in the media itself, that translates into about 0.3 pounds of carbon in the filter. And then again, if you have 24-24-2 at 500 GSM, now you're talking almost 1.5 pounds. So the carbon load in the filter does matter. If you have the space and you can take it up to a 4-inch filter, now you can see you're obviously now almost doubling from the beginning side of it. So carbon load matters. I'll show you here a graph here in just a second, some dynamics behind that as well. When I talk performance with gas phase filtration, I usually like to talk breakthrough versus efficiency. It's just the inverse of efficiency. So for example, you can see that first curve on the bottom down there, that's just orange reddish color. Its initial breakthrough is 10%, which means it's about 90% efficient, taking out the contaminants that you want to take out of the air. So in this case, these filters were tested against toluene at a very high concentration. So just to accelerate the test, toluene is a VOC, a volatile organic compound, which is a very common contaminant that's out there that we see in the industries that people want to take it out. And carbon is very good at taking it out. In this case here, I don't have the loadings necessarily specified there, but that orange curve would be somewhere around a 500 GSM carbon filter. And as you go up through the curves, those are just lighter loadings of carbon in this particular filter. So why does carbon load matter? Again, depending on what you're trying to accomplish, it matters a lot. So for example, that very top curve, it might have 50 to 100 GSM of carbon in it. It might be a 1-inch filter. The amount of carbon in that filter is much less than the bottom one. So what does that do? When we talk breakthrough, you can see that its initial breakthrough is more around 60 to 70%, meaning it's only about 30% efficient taking out the contaminants that you want to take out of the air. Other types of pleated products, again, that I'm sure you're familiar with from the particulate world we have deep pleated rigid cell filters. Those typically can have somewhere between 7 to 10 pounds of carbon in the filter. Come in various types of frames, metal, plastic, whatever your desire is and whatever your need is. They do typically have a pretty low pressure drop. So when going back to the pleats, obviously the lower loading that you have, the less dense it's going to be, the lower pressure drop you're going to have. As you go up in carbon loading, you're going to have a higher pressure drop. So just for example, and there's tons of variations, but a typical 24-24-2 500 gram per square meter pleat might run in the 0.4 to 0.6 range initial pressure drop at 2,000 CFM. These rigid cell filters can run as low as somewhere around the 0.25 to 0.45 range, again, just depending on what you have in there. And then there's a couple other styles of mini-pleat filters. You have like a 2 and a 4 inch mini-pleat. You can even go up to a 6 inch mini-pleat. Very similar to just a normal die-cut carbon pleat, but in a sturdier frame, a little more robust for the type of applications where it needs it. And then there's samples out in the room back there you can take a look at, as well as the V-Bank style filter. I've seen a couple different ones out there. Very good filter, 8 to 12 pounds carbon per filter, very low pressure drop, sometimes can range between 0.3 up to 0.5. Just again, depending on what you're looking at. So, and it comes in different variations of some combinations as well, go into here in a few minutes. As we move along, other types of products that you can get. Oh, let me back up real quick. These types of filters and the pleats, the typical mesh size that you're using, which is again the terminology that we use with chemical media, is 20-50, 20 by 50. So to put that into perspective, it's if you were to think of a handful of sand, that's more or less the same size of the carbon that we're talking about that we put in these filters. It's small because you want it to be a thin media so that it can pleat well, have nice crisp pleats, and have a low pressure drop. So as we get into these thicker products, so one product is a thick media product. So it's a 1 inch nonwoven. It has a larger size chemical media in it. So we call it a 6 by 12, 6 by 8, 4 by 6. I mean, so again, and it's more of what you consider small stones or pebbles, that size, and maybe even a little bit smaller in some cases. But this particular product here is a product that you can have a very, very high loading of carbon. So again, as you can see here, it can be anywhere from 3,000 plus grams per square meter of carbon load in it. So it does have that differential size of carbon in it, which again, very high capacity for a larger size carbon, meaning if you've got a high concentration of gas in the air, you typically want as much carbon as you can get in there. You want it to scrub the air, get the contaminant out of there. The smaller carbon, because you have thousands of more per square area, you have a lot more surface area, so it's going to be much more efficient, but not as high capacity. And again, I could go into this for like 5 or 6 hours and get really geeky and about the science behind it, but I'm not going to. We can talk about it if you really want to in between sessions. Other types of products that have the larger size carbon are what we call loose fill panels. Again, typically somewhere between a 1 inch and 4 inch depth. These are good scrubbers as well. So again, high concentrations. This is where we typically will recommend these types of products versus a pleat. We're going to recommend a pleat again if it's a very, very low concentration, nuisance odor, something that's not harmful to the area that you're in. These products are good, but the pressure drop is a lot higher than you'd see on a typical pleated type air filter. So again, it really just matters on what you're looking at and where you want to go with it. These products here, these are what I consider like the workhorses of the industry. So when you really have an issue in a normal space, again, meaning an HVAC space, I mean, there are scrubbers that are made that have sometimes 3 to 6 feet of media in it to take out really, really harmful corrosive gases out of the air. But if you're talking, I got a standard filter frame, I need to retrofit a normal V-bank filter that I have in a hospital right now, what's your recommendation? Of course, as Dave mentioned, we start asking questions like, well, what's the contaminant you're trying to get out, any known concentrations, and then we usually get a lot of blank stares. So if you can usually just try to direct us in the right area, we can usually recommend the right product with the right blend of chemical media in it. So these 12-inch V-banks are different from the mini-pleated type filters that I showed just a few minutes ago, whereas they actually have 1-inch carbon panels. So again, good for scrubbing high concentrations, and because of the design of the filter, it actually has a fairly low pressure drop, somewhere around 0.4 to 0.5 inches typically, initially. And then the cassettes, again, even more so, if you look at the 12 by 12 by 12 filter, they range anywhere between 14 to 24 pounds, again, depending on the density of the chemical media you're putting in it. And if you wanted to fill a 24 space and retrofit the frame, I mean, you're talking, you would almost have somewhere in the range of 70 to 90 pounds of carbon in that space. So it really just depends on what you're looking at. So a lot of times in the industry, when you have an issue, it's good to contact whoever your carbon representative is, go through what the problem is, what the contaminants are, and if you can get the person on site to help do a site survey, that's really helpful as well. And then I talked carbon size. This is just a slide here that talks to the effect of the adsorption kinetics, essentially, which means that the smaller the size of the carbon is, the faster it's going to absorb the concentration of material into the carbon, for example. Meaning, again, if you have a pile of dust, essentially, that's up there versus a pile of rocks. So there's a X times amount of surface area on the dust as there is on the rocks, because you have more per square area that you're looking at. On the flip side of things, you have more capacity on the pile of rocks because it has the same amount of pore size, but the efficiency when you have very, very small particles is going to be much higher than the efficiency if you have the larger carbon, but the capacity is going to be much higher on the larger sizes than it is on the smaller size. So again, just depending on what you're looking at. On the flip side of things, because it's more dense, the smaller is going to have a higher pressure drop versus the larger ones are going to usually have a lower pressure drop. So again, depending on just what you're looking at in your application. I'm going to turn it back over to Dave, go through his nice little graph here.
Thanks, Sean. So this is a very simplified flow chart. I have a more complex one I'd be happy to share with anybody that wants to see it. But what I get questions a lot of times are, okay, Sean just went through all those different type of filters. How do you know which one to use when? And it really boils down to a couple little simple decision points, really. And before I even get to these decision points, this is Dave Schaaf, not Dave Schaaf, AAF Flanders, or Dave Schaaf, NAFA, but just Dave Schaaf's opinion. If you ever see a concentration of over 100 parts per billion of a contaminant, then I wouldn't use a filtration device unless you're prepared to change it possibly weekly. All the different filter products that Sean was showing you typically don't have enough bed depth and enough chemical media in them to last that long for higher challenges. So I tend to cut off filters at around 100 parts per billion. You can use them for higher concentrations, but odds are you're just going to have to change it out more often, so just be prepared for that. So with this flow chart, the idea is to kind of walk you through what you need to look at is, do you need, and Sean's going to touch on this a little bit on the retrofit stuff, but first thing is you have to talk about if you need particulate filtration in conjunction with the gas phase filtration. Typically, when it's a new product installation, we find most people just want a gas phase filter and they'll handle the particulate filtration separately. Sometimes people want combined. But there are more products available on the filtration side that are just gas phase or molecular filtration than there are combination, but there's a fair amount of both. Other thing you have to take into consideration is how much space you have available. And sometimes, this is where this ties back into my initial comment about the 100 parts per billion. Sometimes you're stuck, you've already got an air handling unit designed where you don't have enough space to put in, say, a 12-inch deep filter that you would like. All you have is maybe 2 or 4 inches. In that case, you have to go with a pretty much some sort of pleated filter like some of the ones that Sean pointed out. When you have more space available, it's always better to go with a 12-inch product if available, because as Sean noted, it has a lot more weight of chemical media, and typically the beds are a little thicker, so it can handle not only higher challenges, but it can handle higher challenges for a longer period of time. So this is just kind of a down and dirty flow chart just to help you kind of get started in the right direction, like what type of filter family should I look at and what depth should I look at. And this is something that's I think is very important. I see this a lot where we'll see a specification and somebody will say there's only one product that will work. Well, that's not true, and hopefully I can convey that to you with this table. So Sean was talking about toluene performance, and this chart says VOC concentrations, but this was specifically toluene because that's what's typically used in our industry as a surrogate for all VOCs. So across the top, you have the VOC concentration or toluene concentration from 10 to 1,000. Down the left-hand side, you'll see different type of filter families, from pleats to V-banks to the cassettes that Sean was talking about. The numbers in the boxes represent how long in months that product on the left-hand side will work based on the corresponding VOC concentration across the top. So if we look at, let's go midway. So if we look at 50 parts per billion, and let's go down to a 12-inch V-bank, and you go across, you'll see it lasts about 4.8 months. So what this table does is it's kind of a quick reference. So I've got a VOC concentration of, something, maybe it's one of those numbers or somewhere in between there, and you know how long you want that filter to last, then you could see which product you should pick. Now, if you go, the ones that are in solid blue are typically going to be 6 months or longer. Based on my experience, people want their gas phase or molecular products to last at least 6 months. So that's why those are in blue. The other three that are kind of that light shaded gray, that's sometimes acceptable. Sometimes we'll see, 3 months is, well, I'm okay with that. So those, okay, I realize 2.7, 2.6 isn't 3, but I'm rounding up. So that's close. And then everything else obviously is less than that. So if you had that 50 part per billion concentration of VOCs, maybe you say all I've got room for is a 4-inch pleat. You can use that 4-inch pleat, but it's only going to last half a month. That may not be desirable, but it may be acceptable because that's all the space you have. So the idea here is there are different products that may work for your application. It's just a function of how much space do you have, and then how long do you want it to last. And you may have more than one product that will work for your particular application. And you can build this same chart with any type of contaminant and get very similar results.
So getting back into the products, I forgot to mention earlier, with all those other products that were shown, they can be made just straight carbon media. They can have a pre-filter media layer on it to help with some dust holding capacity and also help with some efficiency from a particulate side. So in this case here, what I'm going to show now are primarily the filters that are used with combination particulate media and carbon to help with both the particulate efficiency and the carbon filtration part of it. So again, this is just a standard pleat. Typically what we're seeing out there in the industry right now is they'll vary anywhere between MERV 7 up to MERV 13 as a particulate layer. And then the carbon loading can be somewhere between 100 to 500 grams per square meter, all in your standard sizes, 1 to 4 inches. Again, along with this, and especially on the next filter I'm going to show, which are the more efficient filters, One thing I'll point out that is very important as you're trying to figure out what you're going to do in a system is you say, hey, I need a MERV 15 filter, but I've got a pretty bad odor coming through the building right now. I want to be able to put that filter in for a year so that it will obviously keep that odor out, but yet keep its efficiency from a particulate side. So if that filter space is not pre-filtered properly and that MERV 15 filter might reach pressure drop before you need to change out the carbon side of it, you're wasting the carbon. And quite frankly, the carbon a lot of times is the most expensive part of the filter. So if you've got the space, obviously you might want to do two different filters, a MERV 15 pre-filter and then a carbon filter behind it, so that you can change out that MERV 15 and the carbon may still be good. How do you know it's still good? Typically somebody will tell you in the building whether it's good or not, depending on what you're trying to get out of the air. If it's a gas, a harmful gas to a process or something, it's a little bit different. And there's usually monitoring devices and everything else that are in the facility. But on the flip side of things, if you don't have the space, there are all kinds of filter clips and different frame retrofits that you can get now where you may be able to clip on a 4-inch MERV 13 in front of a carbon, take out that MERV 13 when it's used up and replace it so that you don't mess with the carbon filter until it's used up. Coming from the carbon industry, I probably shouldn't say that because I want to sell more carbon, but again, to be honest, it is what it is. It's the carbon filter is usually an expensive filter, and you want to make sure that you're keeping it in the system and it lasts as long as you're saying it's going to last. Additional resources. So essentially, there's a couple different resources that are out there that you can look into. There's the guidelines for recommended practices, and then there's the ASHRAE TC meetings that everybody can happily join if they'd like every year in February. But on the flip side of things, again, the carbon world is it seems to be pretty small in comparison to the rest of the filtration world. Sometimes I feel like a very small piece of this industry, but it's important, as you can see, hopefully, through what Dave was showing you and the products that are out there to take care of what you need. And I think with that being said, we're done. So same process as before. Any questions that you guys have, they're going to walk around with the microphones. If you could just wait until the microphone gets to you, and we'll get the questions answered. And any questions that might come up from here on out through the rest of the week, Dave and I will be around. Please feel free to reach out to us.
I had a question. So wildfire smoke is a growing concern across, the country and the world. What type of filtration setup or style or the amount of carbon are you seeing trending towards correcting or helping filter out that?
Yeah, that's a great question, because again, that varies seasonally, obviously. Again, it'll be interesting to see how this year comes along, with most of them being out in the West, and the West has been drowned by water and snow this year, so hopefully they won't have as many wildfires. But to answer your question, typically what we'll see is because it's a pretty high concentration of smoke that's coming in there, you want something that's fairly heavily loaded, but something that can be replaced fairly easily as well. So again, it might be a heavily loaded pleat, that if you have a space for a pleat. A lot of times what we'll see is somebody will just put up a carbon loaded blanket on the air intake with some different types of holders for the media, so that again, it might only last a day and you have to take it off and replace it. And hopefully that smoke won't be around for more than 3 or 4 days in that area. So, it sounds like a lot when I have to replace it every day, but, if you want to make sure you're keeping your indoor space clean, and that's typically what we see as a recommendation.
Just add a couple things. So the Were you in Idaho by any chance? You missed I did a presentation on wildfire smoke, and I'd be happy to share that with you if you want to look me up later. But the big thing with wildfire smoke, too, is that the majority of the contaminants in the air are particulate matter as opposed to gas phase. So if you do nothing, you want to have at least a minimum MERV 13 particulate filter. And that's what I see a lot is most people, it's like, sadly for Sean and I, since we're both in the molecular filtration business, most people think of particulate filtration first. And that's fine, especially with wildfire smoke, because you're going to get most of the contaminants out. But then, like Sean said, if you can, then you also want to do a carbon filter. And the nice thing is there are plenty of carbon filters out there. You can get MERV 13 combination carbon filter and particulate filter. The thing is with wildfire smoke, like what Sean was mentioning, that's a perfect example of if you buy a combination filter, there are people that change out their particulate filters daily and weekly in a smoke event. And so if you buy that, odds are it's going to get used up before the molecular media is used up. So that's a good example of an application where you might want to use separate filters if possible. If not, then just be aware that if you're using a combination filter, you're probably going to have to throw it away with some good media in it because it's loaded up full of all the particulate media.
There's lots of room air purifiers out there that now have molecular filtration in them. From all your research, what have you seen as the best design people should think? And I'll get it like the scope smaller, like a home or small office space.
I don't have a whole lot of experience on the room air cleaners. I will say, again, going back, I hate to keep plugging my presentation, but for wildfire smoke, that's like one of the best things you can do is a portable HEPA unit in the location. I would say my personal use at home, I'm not plugging Honeywell, but I have a Honeywell room HEPA filter, which based on the monitoring I've done, seems to work pretty good. It has, the pre-filter actually is a carbon filter, right? It's black, must be carbon, and it collects, it's like the pre-filter for the HEPA filter. Does it really remove any odor? It probably does a little bit for a while, but to Sean's point, he talked really, the most important thing with molecular filters is you have to have enough chemical media present for it to do anything. The other thing is not only do you have to have that volume of media, but it has to have enough bed depth to capture. So like Sean was talking about 2 and 4 inch pleats, if you have a high concentration, he was showing those breakthrough curves, and that's what happens when you have those higher challenges, is you're going to capture some of it, but some of it's going to blow right through. And that's the potential pitfall, I guess, with a room, just a room purifier, is hopefully being inside, maybe you have a lower concentration than outside, but there have been a lot of studies, there are a lot of them lately, that said indoor air is worse than outdoor air. So, and that presentation I gave, there was an EPA study where they studied this church where the smoke count went down, but inside the church, it stayed elevated because there was no ventilation. So I don't know if I'm answering your question or not, but I don't know that anything's better or worse than anything else, but I would strongly encourage, if somebody was buying a purifier, to put some sort of molecular filter in there, because even if it's not for a wildfire event or even if it's not for a specific event, if you just had a personal VOC sensor with you all the time, I think a lot of people would be surprised at just the VOCs that are in there. Like for your personal space, your house, anytime you cook, if anybody's wife's like my wife, likes to light candles, anything like that, your dog odor, that's always in there, so you can't go wrong. I've never seen an application, I don't know if Sean has, where somebody put a gas phase filter in and it didn't do anything. I mean, there's always stuff you can capture. The important thing is just, if you know what your contaminants are, make sure you've got the right chemical media for those contaminants, and then, if possible, the concentration so you have enough media in there. I think from what I've seen, trying to go back to answer your question in a roundabout way, is most of those purifiers, everybody's focusing on the HEPA filter because everybody in the industry tends to focus more on the particulate side. I haven't seen a whole lot of them so far with the gas phase products. In fact, just being completely honest, our own product doesn't have that right now.
So I enjoyed the VOC concentration table.
Oh, great.
Are there are there tools for us to get those numbers in the field effectively, accurately? So, right. So the table's great as long as you
Yeah.
can get the numbers, right?
Yeah. So the short answer probably is no, not necessarily, but if you have a gas phase or molecular filtration company you work with or know of, they can typically provide you with that. So like for our customers, I do that kind of thing all the time, because what I find is where that table comes in really, how many people in here are in sales, by the way, just out of curiosity? Fair amount, okay. It's a great sales tool, because what happens is a lot of times, as Sean and I both have mentioned, with molecular filtration, you don't know what the concentrations are. Nobody measures that. But if you can at least get what the contaminant or contaminants are, that'll go a long way. And if you can build a table like that, then you can show the customer, okay, you weren't be able to tell me what your concentration was, but if you're in this range, here's the filter, our filter products I would recommend, and here's how long they'll last. And at least you can kind of ballpark it and kind of frame it in for them instead of just saying, well, I have no idea.
Gotcha. If I can just add to that, I mean, dialing it in to the filter type is the main thing that table is used for. The hardest part about the concentration levels and how long it's going to last is you're never going to know when there's going to be that blast, where you may have a constant concentration for 3 or 4 months, and then you might, let's just say a hospital, for example. I mean, again, you guys are in the Chicago area, right? So you're down there in the middle of all this huge area of construction that where they might have just a normal concentration coming into the hospital with that typical 4-inch pleat's going to take it out. Then all of a sudden they start building right across the road another building and tarring a roof. Now your concentration levels are spiking. So, but the nice thing about that table is you should be able to at least dial in to say, based off of what I know, I'm either going to use a 2-inch pleat, or I'm going to use a cassette or a 12-inch feed bank, or whatever it may be. So,
Another question? So during the pandemic, the whole world was doing anything they could do to figure this out, and there was some undercurrents that would suggest that chemical filtration or gas-phase filtration might play a part in contagious disease control. Has there been any development in that area? What are your guys' thoughts, opinions in that area?
So historically, the potassium permanganate impregnated alumina is, if you just Google it, the potassium permanganate, it's known to be a antiviral. It can control certain, I haven't seen anything specific to COVID, but I have seen published reports. I've even seen, for anybody that's interested in like grow rooms, started off that most grow rooms just use virgin activated carbon because most of the terpenes are VOCs, and so that would remove it. But then some people started instead of doing a 50-50 blend, do like a 80-20, 70-30 blend of activated carbon and potassium permanganate on alumina, and found that the alumina, that potassium permanganate also helped kind of curb mold growth. So activated carbon in most of the various forms, I would say, from what I've seen, what I know, wouldn't do anything, but potassium permanganate does have some ability to help with certain things like that.
Hey, long-time listener, first-time caller. Got a question thank you very much, from Chicago. Hey, everyone. On a 24-24-3 basic filter frame, is there a certain weight that is rated to, or maybe a certain weight as we look to upgrade that we might reinforce a frame?
I'm not familiar with any specific weight. I mean, all those filters that we showed have been used in those standard frames with no issue. I mean, now there are some applications I've been in where if it's a heavier filter, let's say more on the range of that 25 to 35 pound range, you definitely need to make sure it's clipped in properly. I've been in some applications where the filter was just put into the frame. It may have a pre-filter in front of it. The pre-filter fell out onto the floor, and the filter's curved in this way because of the weight of the filter. So, matter of fact, I was just in a hospital not too long ago where that was the case, and all the people that installed the filters, the clips were there, to clip it in. They just didn't clip it in. So as long as you have the proper clips, I think the weights are fine on the standard frames.
Thank you.
Could you touch on the relationship between media velocity and the grams per square media or grams per square meter of charcoal and dwell time and the relationship involved there?
So there's a term that I didn't get into today that's pretty important, but I didn't want to get that deep into the weeds, called the mass transfer zone, if anybody's familiar with that. But it basically has to do with how deep of a bed of media you have and the velocity of air going through it. That's the residence time. And then the mass transfer zone is a given contaminant at a given concentration occupies so much space in the air. And say, like, just in this example, just want to remember off the top of my head, it's like hydrogen sulfide at a concentration of a part per million, 1 part per million, going through a bed of 4 millimeter activated carbon pellets, which is a typical size for deep bed applications. It consumes a space of around 6 inches. So you need it. What that means is you would need, and this is typically at, say, 75 to 100 feet per minute, you would need a 6-inch deep bed to fully capture 100% of that contaminant going through it. If you have a pleated filter or something that's only 1, 2, or 3 inches, what that means is you're going to have immediate breakthrough. Your mass transfer zone is longer than your bed is deep. And so what you can do with that mass transfer zone, obviously, if that's a problem, is slow the velocity down. That will shorten the mass transfer zone, therefore give you more residence time. So it's a little game sometimes you have to play depending on what the contaminant is. Typically with most of the filter products that Sean showed and we talked about, those normally people are running those like a standard HVAC filter at 500 feet per minute. So your residence time is really low. And if you have a high, that's why I said that 100 part per billion. If your mass transfer zone would be too long, it'd blow right through those filters and you shouldn't use those. Did I answer your question? Or? Okay.
Yes.
I think I can just add one real quick thing to that. Those breakthrough curves I showed, none of them were, 0 at the beginning. There was always a breakthrough at the beginning. And again, it goes back to what Dave was just talking about. I mean, there's just not enough depth in that filter for it to be 100%. There are processes out there and certain applications where people need 100% efficiency with chemical media. Now you're talking a whole nother level of non-HVAC type of applications, usually deep bed scrubbers and things like that. So, if an odor, for example, typically let's just make it easy. You might need it to be 10 parts per trillion to smell. So if that filter can take out 5 parts per trillion for an amount of time, then that odor goes away. Now the customer is satisfied. If that makes sense.
Yeah, one other thing on that, Sean made me think of something. A lot of it depends on the application, whether you need single pass efficiency or not. So if it's one pass through the media and you need to capture it, all of that's much more important. But if you're in a recirculation mode, if you didn't capture it the first time, hopefully you'll capture it the second or third time. That's not as important.
What about carbon monoxide? Can you use any type of molecular filtration? Where I live, freeways are parking lots for most of the day. Is there anything, along the freeway zones that will help something with carbon monoxide or the off gases from vehicles?
So are you familiar? There's a gas phase term I show in a lot of presentations. We didn't show it today, but dilution is the solution to pollution. That's carbon monoxide is one of those, or the old term aired out. There really isn't a standard chemical media that will remove CO or CO2. There are some specialized medias out there that are a little more catalysts in nature that will remove that. The problem is I've yet to see anything in our market that has enough capacity really to tackle something like that. Most of those types of medias will remove certain amounts, but then they have to be regenerated overnight because they've used up all their capacity during the day. So I'm not aware currently of anything that's really a good solution for that, other than, like I said, just airing it out.
Can I ask one more? All right, so say I have a 4-inch track and you don't know the contamination levels. So you could either do 100, 200, 500 grams per square meter. I walk into a room and it's an odor. What you smell is gonna be different than what I smell. So where's our starting point of how many grams per square meter? Do we go just start in the middle and plus or minus?
Depends on how much money you have to spend.
I like that.
Again, I mean, typically, I may say, let's try something in the middle and see what effect it has, and you may put it in, and it may do fine for a week, and then all of a sudden you can smell the odor again, and then that gives you a little bit more guidance to say, okay, we use 250 GSM, we got something we can bump up to 500 or even 600 GSM. You know, it's going to give you more time and less change out. And again, obviously, it's going to be more expensive, but it also costs money to change a filter out too. So you look at the total cost of ownership when it comes to that.
Thanks for listening to the Talking Air Filtration Podcast, a production of the National Air Filtration Association. Clean air matters.